Oh, okay. Let's get started. First of all, welcome. Thank you for coming. My name is Guillermo. This is my first time attending and speaking at the conference, so I might be a little nervous. Thank you. Today we'll be talking about my journey and my experiences while applying microservices patterns to a modular monolith. So a little bit more about me. That's my pretty face and a helper to pronounce my name. So hopefully it helps you guys. Those are my socials. Feel free to follow me. Probably the most interesting one is GitHub. Still use LinkedIn, so feel free to follow me there. I'm born and raised in Montevideo, Uruguay, South America, and I've been a Rails developer for almost 6 years now. And I work at Bootstrap. We're a Uruguayan American company with hubs in Argentina, Colombia, also Uruguay. And we provide services from staff augmentation or just building products from scratch. So thank you very much to them because they brought me here. And to talk. I'm gonna run a little bit of the agenda. So first we're gonna start with my journey, basically my experience in my career and how this talk came to be, what are the things I learned and where I'm at right now in the current project that I'm working on. Next, the domain, because we're gonna be following an example throughout the app, throughout the presentation. So we're gonna introduce the domains to set the basis for the app, to set the basis for the demo. With that, I'm gonna introduce the concept of patterns. You probably already know about patterns, but if you don't, I'm gonna introduce the concept and explain what they do, what they aim to solve, and we're gonna go into the example app that we are gonna be seeing right now, with a final demo to show that everything works. Well, my journey, as I said, started 6 years ago, and I started learning Rails and started working with simple projects, simple monoliths, MVPs, that kind of thing. And then I got moved to bigger monoliths, bigger projects, and with those came different challenges and constraints. I'm gonna show hopefully a good example of what I faced with the big monoliths, and hopefully you can relate. Then I got moved into a microservice project. So kind of been bouncing around different architectures and been learning a lot through them. And in the project that I'm right now, we're using a monolith and modularization. So a little bit about monoliths. As I mentioned, everything I started with was a monolith, and they're good. They're widely used. There's nothing really wrong with them. If it fits the needs of the product, I probably think you should use it. That's basically, they provide a lot of set of functionalities or a lot of concepts that are very familiar to smaller apps. But once the product starts growing and the app grows with it, and so does the teams and development teams, we run into several issues. And the problem is how we handle that growth. So, as I mentioned, I started with MVPs, simple projects, and I got moved into a big monolith. And my first experience was this. So, please raise your hand if you've seen something like this. So I'm not the only one. Okay, thank you. Good to know. If you're unfamiliar with bigger monoliths, this is very common to see that the user model is very bloated with 2,000 lines of code. So bigger monoliths tend to have the problem of having more dependencies, bigger models, tightly coupled code. And so they come with their disadvantages. So in my experience, they take longer deployment times, spending like 30 minutes, 40 minutes for a simple change to get deployed. Or, as I mentioned, tightly coupled code. That basically means that we have harder to maintain and to extend code. Some features cannot be implemented until we deal with the bigger code and the dependencies. So that was more or less my experience in monoliths, and that's what I learned from that project. And after that, I moved on to microservices. Complete opposite, you can say. And I thought, okay, change of scenery, everything could be great. Smaller cohesive teams means everyone on the team knows the service, knows the context, knows what they're working on. And we get also the benefits of it being distributed. We can just ship a change for our service quicker. We don't have to worry about other things like in the monoliths. But the project, in my experience that I worked at, didn't have any of these benefits. Basically, it was like the stereotypical bad microservices project. So it had a lot of data inconsistencies. Services didn't communicate well with each other. Everything was kind of a mess, which meant we were tasked with hot fixing issues in production, which, as we know, is not a good time to have or a good idea. So microservices also come with a set of disadvantages, especially in my case, like it meant significantly higher infrastructure complexity. Now it's like we move away from the big monolith complexity and we move that complexity into the actual deployment of the app and how everything communicates. And if we don't do that right, that step is crucial for the success of our architecture. And also, it can get to very messy and with a lot of services going around. So we have to take care of that. After that beautiful project with microservices, the project I'm currently working at, little context, is monolith with multiple databases that we're actively trying to modularize and move away from those big monolith problems. And the word modularization, I first known about it reading this article from Shopify. It's a couple years old, I think from 2019, but it was a great example as to how to tackle the process and basically not knowing that you're not alone in having to deal with bigger monoliths. And within the article, there was this image that I related heavily with, especially because I spent my entire career up at that moment in the lower half of the image, going from a monolithic big ball of mud into a distributed big ball of mud. So now, trying to modularize the project, I'm trying to reach, finally, the upper half of the diagram. So how can we reach a good modular monolith? How can we avoid the problems that we carry from monoliths, the problems that we carry from a distributed system? Because even though it is a monolith, we still have to have some type of distribution, especially around communication between the modules, because we want that isolation between them. So how can we do that? Probably not the first to have this idea, but I thought, okay, why can't we have some cross-pollination between architectures? Why can't we grab the best things that microservices have, the best things monoliths have, and probably we're gonna face the same issues in our modular monolith. So why can't we leverage and reuse that knowledge in our system? So that is kind of the backstory. That was kind of how the idea of this came out to be. And I was like, okay, I cannot test everything in my project in production or anything. So I created a kind of a simple example to mimic what I was facing in my project to test what I wanted to test in my ideas. And that is this example that we're going to be following throughout the presentation. So the main concept is a simple app that allows members to schedule meetings. We have kind of like two domains. One is meetings, the green one, or the right one? Okay, yeah, it's flipped up, sorry. And that handles the member model and the meetings model, and that member is of a type user, and that user has a user registration. The domain of user access is gonna be to handle registration concerns, policies, roles, stuff like that. So meetings is more product-oriented, the other one is more like registration stuff. And for the sake of this example in this presentation, to keep it simple, we're going to focus on user registration, and the member. So you can forget, we can schedule meetings for now. We're going to be following an example that is just a user registering in our platform and how that can get tricky. So you might be thinking, okay, that sounds a very simple example. Why do we have to separate everything? And you're probably right. We can very simply diagram this application, and I would do it like this, so we'd love to know how you would do it, but this is a very simple monolith, one member model, belongs to dependency from two other models and one database. But this didn't serve the purpose I was trying to achieve in mimicking, so I split it. So now we're going to have kind of similar to the other diagram, the same two domains, but we're going to introduce one database per domain. So we're going to have a meetings database, and we're going to have a user access database. Leaving the one database behind might be simple, but like on the surface, but it doesn't come up without its problems. So when we have one database, especially a relational database, we have transactions, and those get ensured by these 4 properties. I'm not going to go into detail into these ones. I'm going to focus on atomicity. Basically, it means that everything gets treated as a unit, as an atomic unit. It doesn't matter if a transaction has multiple steps. If something goes wrong, it fails, and it rollbacks the changes, and we end up the transaction with a consistent state. But when we leave the single database behind, we lose the ability to basically roll back all the steps, because we're not dealing with one database, we're dealing with 2. So how do we get that same feeling of atomic behavior that we had when we're having one database? And you also might be asking yourself, do we have to handle that? Do we have to basically mimic that behavior? As I mentioned, in the microservices project, they didn't. And that led to consistency issues. Everything was out of sync. Some things didn't make sense. It was very hard to debug. Fixing data issues in production. A user might get billed some incorrect number. You have to go fix it. Highly not ideal to do. And important flows might break. So we expect something to be in the database that it isn't, and we don't know where it got broken. So in my opinion, and at least my experience, it is worth to handle distributed transactions and data consistency in this type of project. I'm going to be focusing the solution into specifically data consistency. So how are we going to handle the simple registration process for our app? And for that, we're going to use patterns. Patterns is a very familiar concept, but if you aren't familiar with it, it's proven solutions to our current problem. Most famously, design patterns aim to solve some of that. And in the context of this talk and in microservices, we're going to be using microservices patterns. Highly recommend you read this book, Microservices Patterns by Chris Richardson. Basically, I'm going to borrow some definitions of patterns from this book. The examples in this book are in Java, which is a problem that I faced while preparing this experiment. All the examples that I wanted from microservices were either in Java, JavaScript, Go, or any other more performant language that gets used instead of Ruby or Rails. So I had to basically implement them. And what are those patterns that we're going to be using? We're going to be using, as you saw on the diagram, one database per service or domain. We're going to be using Saga to handle distributed transactions. And we're going to be using transactional outbox to atomically emit events. You might be wondering, what are those patterns? Very good question. One database per service or domain is quite simple. The main purpose is to isolate the data structure between domains or services. You can implement this using private tables, schemas, or actual databases, which is the one we're going to be following. Saga is for, as I mentioned, handling distributed transactions. It's a way of having an eventual consistency across systems. And to handle distributed transactions, you might have heard of this two-phase commit, which is a synchronous way to handle distributed transactions. Saga is the async version of it. You can think of it like that. And it consists of having a flow of local services, having local transactions with their own database. When they make a change, they emit an event. That event then gets listened to or processed by the following service on the chain, which also makes its local changes. So if anything goes wrong locally, we do have the rollback ability. So we can roll back those changes and then eventually emit events for each service to roll back their changes and end up with a consistent state no matter what. Emitting events comes with its own set of problems. What happens if the service or the message bus service is down and we lose that event? That event might be critical for a system. So we need a way to automatically update the state and publish events as a whole unit. And the way we're gonna do that is with transactional outbox. The concept is we're gonna be persistent events. So taking advantage that Saga uses local transactions, we can use those local transactions to persist the change that we want to make with the event that we should emit when that change happens, or if that change fails. So number one, you can see on the diagram that we're gonna insert something in the user registration table, and we're gonna insert the same kind of event in the outbox table. So that is an intersection, so if a user registration for some reason fails, we can roll back everything and we would have a consistent state. Then we have a message relay, which basically is a worker of some kind, something that polls the table or reads the transaction log, that reads the outbox table and then publishes the event to the message broker. So we have multiple databases, Saga and transactional outbox. So our app now looks more like this. Same diagram on the top, but now domains are going to communicate indirectly via the message bus that we're going to be using. And to identify the same entity of a user between domains, we're going to share an identifier that is going to be the same across the user access database and the meetings database. I leave you with the diagram a little bit. Don't worry, I'm going to explain it, but I'm going to drink. So we have our database, we have our domain, we have everything set up for the example. We're going to be following the registration flow for a user. A user registers in our app, inputs the data, and they get sent a confirmation email. The Saga flow starts there. So what do we do when we get a confirmation email? We confirm that email. And that is going to trigger the whole set of events that we're going to have for the user registration flow. So first, as I mentioned, in the user access domain, the top is the user access, the bottom is the meetings domain. We're gonna confirm the email. Then we're gonna update the status code of that user registration record to confirm. Since that is a change that we want to emit an event for, we're gonna, of course, create an outbox record that reflects that event. That outbox record is gonna get read, published, and we're gonna go into the different flows. So the two domains are going to consume that event. The user access is going to create the user related to the user registration, and we're going to consume that event as well from the meetings domain and try to create the member. I'm going to go into the two flows, the happy path, so everything works just fine, and we end up with a user registration record, which is confirmed, a user record, and a member record, all in each domain. So we create the member. The member gets created successfully. We want to emit that event to let the other domain know. So we're going to create the outbox record. We're going to publish the event, and that's it. We got a full successful registration. But what happens if something breaks on the member side, on the meetings domain? Then we're going to go into the rollback sequence. So this part is important, but what happens if we had to roll back before? We're in each domain, so we are doing a local transaction. So if we want to roll back any change, that gets handled with a typical database transaction. But in this case, which had to roll back across domains, we're going to have to emit the event, member created failed, of course, create the outbox record that gets then published, which is the persistence of the event, and go into the user access domain. We're gonna roll back the change, so we have a user that confirmed, the user registration record was confirmed, now we have to roll that back, we have to set it to waiting for confirmation, and we also have to destroy the record, the user record that we also created. So now, what does our database look like? The same as we started. We have a user registration record that is waiting for confirmation. So we have a consistent state. And that example is what I'm going to show in the demo. Basically, all the implementation of the mentioned domain and how the app looks like. The tech stack that I used, I leaned heavily on the Rails multi-database support. The message bus is going to be Kafka. Personal preference and experience, you can use any message bus, I think, Rabbit, active support notifications, anything. But since I'm using Kafka as a message relay, I'm going to use Kafka Connect, which is simply a service that reads the transaction log and then publishes the event to Kafka. This can be a simple worker that just pulls the database. And to handle the Kafka events from the Ruby side, I'm going to use the Kafka gem. So hopefully it shouldn't be playing right now, but there we go. I'm going to explain a little bit. I'm going to go into the registration process. I'm going to input data for the successful case. So that is me on the left in the browser. The right is the terminal with the logs. Here, I just want to show that on the blue line that is going to appear right now, right there, that is the email being sent. It's not really critical to the flow right now, but just wanted to show that this is where the Saga flow that I explained earlier starts. So we created that record. So we go into the user access outboxes, and we have that event. We have a new user registered event persisted in our database. We then should also have a user registration record waiting to be confirmed, and we do. If you can see on the status code column, the status code 0 is waiting for confirmation because it's default that I gave in the Rails app. So we have a user registration waiting to be confirmed. This is where the Saga flow that I explained earlier starts. We don't have anything else on any other database. User access, users, meetings, members, everything else should be empty, and it is. And now I'm just going to go and confirm the email. Give it time. There we go. So now the flow starts, and you're going to see a lot of things moving, but the important stuff is this. So on the left of the screen, you're going to see the domains. So you're going to see new meetings outbox and new user outbox, user access outbox. Those are the domains consuming the event that is highlighted on the right, which is user registration confirmed. So remember the diagram? We had the top part and user being created and then member being created. That is this process. So we now should have user registration with a status code of 1, so confirmed. We should have a user record, and now we're going to try to create the member. We can see here that we did create the member successfully. So this is the happy path. The meetings domain emits the member created succeeded event, which is on the right. So the user access domain knows that everything ran properly and everything's okay. That's why you see on the left that the user access domain consumed that event. Now we're going to go into the database to actually see the records. So what should be seen right now? We should be seeing the events that we sent being persisted. So we have the event from before, and now we have the user registration confirmed event. The structure of the event has a payload, and that payload has the data that created the event. But now in the user registration table, we can see that we have a status code of 1, so the user registration is confirmed. We go into the user access users table, so we should be seeing a record, and we do. And the identifier there, I don't remember what it is, but you're going to trust me, it's the same one, but it starts with BB something, so should be the same in the user registration table, meaning it's the same physical user, which it is. Then in the meetings outbox table, we should persist the event that we successfully created the member. So everything runs smoothly, and we're in the happy path, so we have a member created succeeded event. And in consequence, we have a member record that shares the same identifier as with the other domain. So we went through the happy path, and everything worked just fine. We had some events being shown, some events being persisted, and we don't have any rollback here because everything worked out just fine. So now I'm going to break the app. For that, I'm going to be using a feature flag. So That is the feature flag right there. I'm going to remove the terminal right now. And the feature flag enabled means happy path. The feature flag disabled, as I'm going to disable it right now, means it's going to break on the member creation step. So the same as the diagram, the member creation is going to fail, and we're going to go into the rollback sequence. That is me disabling the feature flag. It is disabled, and I'm going to just repeat the same process of sign up. So I'm going to sign up with failure, user, and we're going to see the same thing again, because this is the same part of the flow. We see the blue line from mail catcher sending the confirmation email. So if we're in the same step, we should be seeing the same data, right? So in the user access outboxes, we should be seeing a new event, the same one, but I don't know, I moved the mouse right there. There we go. It's an ID too. So it's a new user registered event for the new user that we're registering, and nothing else. So now we're gonna go into the same flow and what kickstarts our Saga flow. So confirming the event, and this confirmation is the one that's gonna break. So we're gonna create the user, like we can see right there. So same as before. On the left, the domain that consumes the event, and on the right, what event is being consumed. So the user access domain consumes the confirmation event and creates the user, and the meetings domain consumes the confirmation event and tries to create the member. What is going to be different is that that step is now going to fail. So we're going to see that the meetings domain right there emits a member created failed event. So now the user access domain is going to consume that is on the left of the screen. You can see that that is the user access domain doing that. It's going to consume that and know that it has to go into the rollback flow. So basically go into the same consistent state as we started. And how does it look in the data? The initial steps look the same as before. So in the user access outboxes table, we should have a confirmation event, meaning that we actually confirm that user. And that is what I'm showing right there. We should go into the user registration table and see that we have a confirmed user registration because we actually confirmed the event. But that is not the case because we see it has a status code of 0. Why is that? Because we actually roll back that change successfully. So the user registration and the user access domain consume the member failed event and roll back the status code to waiting for confirmation. Now, we should not have a user created for that user registration because we destroy that in the rollback process. We don't, and we can see that in the meetings table, in the outboxes, we do have the member failed. So we ran through the diagram, we failed to create the member, and then we emitted the event, and that is persisted here. And in consequence, we shouldn't see any member record in the meetings member table, which we don't. And as you can see, that is the first user that we kind of signed up. And that is it for the demo. So backtracking a little bit, we had our new domain, we had our flow, which is a very simple flow, which is a registration flow. But now we have multiple databases, and things can go wrong. And when they do, we need to be careful and handle those missteps or errors. So we created a member, a user in our system via the user registration, then created a user, then created a member. Everything worked fine. And then we had something fail, and we rolled back everything to the initial state of the user registration waiting to be confirmed. How did we accomplish this? Basically, we have a modularized monolith. I'm using Packwork to do that, to separate the constraints. You can see that the meetings folder just looks like a simple Rails app. It has the consumers folder, but that's for Kafka and handling that. Then we have the user access domain. We had to share one model between the different domains, so that's why we have a public folder there. But other than that, just a normal Rails folder with a package YAML for the Packwork config. Going into the code, this is how we handle events. So this is the Kafka consumer. We have one for user access and one for meetings. you can see that we have the user registration confirmed duplicated because, as we saw, we consume that event from both domains. And that consumption triggers a service that basically does the job. It's a very simple service, which is called create member service. Then you can also see that the user access has the two events for the succeeded and the failed events. So if it succeeds, I didn't show it in the diagram because it doesn't matter for the example, but we activate the user. And if it fails, we just roll back the creation step. How did we create the outbox and everything? This process there's some gems out there, but didn't really fit the needs, so we created the code for this. We basically use the after commit hooks, and we hook into them to create the outbox record, taking advantage that is within a transaction block. It's kind of implicit, but that's how it works. So whenever we make a change, we hook onto that and try to create the outbox record. This is the code to create the outbox record. It's just populating the fields and the payload and the identifiers from the record that is being created. And two things can happen. Everything can go fine or something can break. In the transaction, we can save, for example, the user registration, and that works fine. But what happens if the outbox creation fails? To help debugging, we just added those errors into the main model being created, which you can see right there. And since everything is a transaction, if the save of the outbox fails, the transaction rolls back, and we have, as I mentioned, a consistent state. Moving on to the member creation, it's just a very simple service, but added with the outbox code that we have on the app. Basically, it's just member.save, very simple, but we just specify which event we want that action to emit, which is the created succeeded event. And then for the purpose of being more verbose and for this presentation, if that member creation fails, we emit the member created fail event. And I just wanted to show how you would do this if you needed to create the actual outbox record kind of manually, which is the same as I showed before. The rollback is more or less the same. We take advantage of being in the user access domain, so we do a transaction, and then we just destroy the user and move back the status code for the user registration into waiting for confirmation. And don't worry, I know that the rescue block doesn't do anything, but I didn't want it to do anything for the presentation, but yeah. And that's it. If you feel like you want to have a deep dive into the code, don't worry. I have the final slide with the QR code, so if you don't have quick hands, you will see the QR code later. But it's open sourced. At Rootstrap, we work in this repo as a team as well, and we have transactional outbox examples, Saga examples, Packwork examples, so feel free to contribute and ask any questions or open any issues in the repo. It's meant to do that, so. What can we take away from this, hopefully? Hopefully you go home with new knowledge of 3 widely used patterns to help you in any of your projects, knowing that we can actually handle distributed transactions in a way, and that it is possible to leverage different solutions into our system. We can actually use stuff that is mainly used for microservices into our monolith. But know that it's not a silver bullet. I know that this is a very kind of complicated example. That's why I try to show the simple architecture. This is a road you take if you need to. It's not the best road. It's not the only road, but it's the road I found. And finally, hopefully inspiring others. As I mentioned, this is my first time speaking and attending. I sent the proposal just because I wanted to send it. Didn't know I was going to be standing right here. So hopefully you do the same. Thank you, and that's it. I'll leave the QR code for the repo, and I answer any questions you have face-to-face because I want to get the mic off. Thank you, and that's it.